Right, for this section, we're solving equations that have a radical. So if we want a square root to cancel out, we raise it to the second power because we're taking the second root. They're opposites of each other. Whatever I do on one side of the equation, I have to do on the other side of the equation. So now this becomes x is equal to 49. Same concept on this problem. We raise these to the second power. The radical and the squared cancel each other out, and we have b minus 8 is equal to 4. We're going to add 8 to each side, and we get b is equal to 12. When this says check for extraneous solutions, we just want to check and make sure when I plug in the value that we don't get a negative number under the radical. So when I plug 12 in, 12 minus 8 is positive 4, so everything's fine. For the next one, before we can square, we need to get the radical isolated. So we're going to subtract 7 on each side, and we have the square, oops, not an x. The square root of w plus 3 is equal to negative 4. When we take the square root, we're not going to get a negative answer. The square root is going to be a positive number. So I could stop right here and realize that this is no solution. If I were to keep going and I squared both sides, I would then subtract 3, and I get w is 13. If I plug the 13 back in, I get 13 plus 3, which is 16, and the square root of 16 is not negative 4. So at that point, I could also realize there was no solution. For number 4, we want to isolate the radical, so I'm going to do that by adding 2 on each side. And now I want to square both sides. When I square both sides, the radical cancels out on that side, and this is y plus 2 squared. Y plus 2 squared means y plus 2 times y plus 2. So I want to think about distributing that. When I do, it's going to be y squared plus 2y plus 2y plus 4. And then I've got 2y plus 4 on this side. I'm going to combine any like terms that I have on the right. And then I have a quadratic to solve, so I need to get my equation set equal to 0. When I subtract the 2y from both sides, I'm going to have 2y here. And I subtract the 4 from both sides, there's no constant. To solve a quadratic, I can factor it. Oops. So there's a GCF of y. So I'm going to get y equals 0, or 0 equals y plus 2. So negative 2 could equal y. I have two solutions. I have to check my solutions to see if they work when I plug them in. If I plugged in a 0 here, I'd have 2 times 0, which is 0, plus 4 is 4. Square root of 4 minus 2. It's 2 minus 2. That equals 0. That one worked. If I plug in a negative 2, I'd have 2 times negative 2 underneath the radical. And that would give me negative 4 plus 4, which is going to give me 0. And the square root of 0 is 0. And when I do negative 2, I get negative 2 on both sides. So those both worked. So I have two solutions for that one. On the next one, we want to move one of the radicals over. When I move this over to the other side, it becomes a positive. And now I can square both sides. So So I have 3b plus 4. When I square this side, remember I'm squaring the whole thing. So the 2 on the outside now becomes a 4 because it's 2 squared. I'm going to have to distribute that 4. And now I have to solve for b. So I can move the 4 to the other side, move the b's together. So if I move the b's together, it's negative 1b is equal to negative 8. So b is 8. And then I have to check my solution. If I plug an 8 in here, I'm going to get 24 plus 4. So that gives me the square root of 28. Minus 2. And then if I plug an 8 in here, I'm going to get 8 minus 1, which is 7. And then square root of 28 is the same thing as saying the square root of 4 times the square root of 7. So that's 2 radical 7. So I get 0 equals 0. So this one works.